Okay, here we have one that says a culture of bacteria obeys the law of uninhibited growth. If 500 bacteria are present initially and there are 800 after 1 hour, how many will be present in the culture after 5 hours? And then how long is it until there are 20,000 bacteria? Okay, there's a lot of information here, a lot of things that they're asking for, so we have to figure out a way to take this step by step. First of all, they said a culture of bacteria obeys the law of uninhibited growth. If that is true, then that means that they're telling you that it follows this formula. A equals A naught E to the KT power. That's our formula for uninhibited growth or decay. It's just going to depend on what the K value is as to whether it's growth or decay. Okay, now they say if 500 bacteria are present initially, so that tells us that our initial amount, or our A naught, is 500, and there are 800 after 1 hour. That's our amount after time, 800. That also tells us that our time is 1 for 1 hour. How many will be present in the culture after 5 hours, and how long is it until there are 20,000 bacteria? Nowhere in there are they telling us what rate it's growing at or what the proportionality constant is, but they have given us enough information right now to find that proportionality constant or that growth rate. In fact, if I take what they gave us right here in just the first part of that second sentence, then I can plug that into the formula. So A would be 800 equals A naught is 500 E to the K times 1 power. Well, K times 1 is just K. And I can solve this. I can divide both sides by 500. And by doing that, then we have 800 divided by 500. Well, that will reduce down to 8/5 equals E to the K power. And again, now we can introduce logs, so we can bring that exponent down in front. So that's going to be the natural log of 8/5 equals K times the natural log of E. And hopefully by this time we're getting the hang of that the natural log of E is just 1, so we don't have to worry about that. So that tells us that K equals the natural log of 8/5. Now we know what K is, and we can use that in our formula. For the second part says how many, so let me do this. Let me block this off. So this is our second part of the question. How many will be present in the culture after 5 hours? Well, if we're going to use our formula of A equals A naught E to the KT power, we have variables of A naught, K, and T. If it's asking how many will be present, that's this A value. That's what we're going to be solving for. How many were present initially? What was our starting amount? Well, we already know that to be 500. Our K value is the natural log of 8/5. We just found that. And our T in this case will be 5 because they want to know how many we'll have after 5 hours. So now we have enough information to plug in and solve this. So that means A will equal 500 E to the natural log of 8/5 times 5 power. Now this can be done on your calculator, but remember you have to be very careful about your order of operations. This entire numerator needs to be put in parentheses to make sure that you're doing the entire thing. So on your calculator, type in 500 E raised to the, it's going to, if you hit the E to the X button, it's going to automatically put in a parenthesis. If not, if you just do E and then up caret, you'll have to put a parenthesis. And then natural log, it will automatically put in another parenthesis, so you'll have to close that after the 8/5, and then times 5. You should get, if you enter it in correctly, you should get, excuse me, 5,242.88 bacteria. And we will finish the last part.